already been described. And this is all about how we actually ended up doing the things that we did that Stephanie spoke about and Arun spoke about before. So what is Jiva? Essentially, we are creating ways in which you can create what we call sovereign AI solutions, or AI solutions that you can own yourself, the IP that you can own yourself. That includes data science, includes machine learning, as well as the more sexy AI stuff that everyone's talking about right now, large language models and things. But we want to do those things in a way that is very easy for, say, clinicians or non-technical people to do. So if you wanted to create a machine learning algorithm that detects a particular disease from certain data, we wanted to make that easy for non-technical people to be able to achieve, rather than just data scientists and programmers. So that's what Jiva is all about. So there's various different things that we did in this project. As there were 3 different engagements, and I won't go over the same stuff that we went over before, but the liver disease model was worked on by Mo. That was what Stephanie and Verinder were talking about. Ramesh worked on SDE integration, so that's getting the Jiva platform into the secure data environment within Manchester. I'm not going to be talking about it either, but I will be talking about the clinical pathway automations that Tanisha spoke about. So that Tanisha developed with the team. So I just wanted to put this slide. This is a little bit old. It's a couple of years old. I'm sure it's different now that I found it in a paper. And I think we're quite obsessed in the health tech kind of space on getting diagnostic type AIs out in the open and doing those things. And obviously they have very big impacts. I personally think actually the administrative side of healthcare is probably way higher impact and easier to actually create. So those kind of things that administrative staff and clinical staff do in a hospital or a clinical setting that are almost completely automatable in some cases. And this is what we wanted to concentrate on in this particular part of the project. Well, this is not good news for scanning clerk, who apparently is completely automatable. But I think in general, AI has a great potential to automate across the board. I don't believe that AI should be doing whole jobs. I think that's a really bad idea, at least for now. A human should always be in the loop in these things, and that's exactly what we did in this particular project. As Steph and Bruno were describing before, on the machine learning project that we did in Liver, where we were detecting, we were predicting liver disease from source data. What we wanted to do was bring that to life, and also create some automation around letter generation that would then go off to the patient to take the next steps in the clinical journey. I think there is a video, I hope. Yeah, do I just press it? There you are. So as you can see, this is all delivered on a Google form, so nice and easy to create. There were loads and loads of different data verticals as part of the machine learning algo, as well as the required for the letter generation. You can actually have these as unstructured text rather than just numbers and things like this, and we built that capacity into the AI to be able to understand those things. So Stephanie would, or whoever, would go through those, fill them in, hit submit, and when they hit submit, that would end up in Google Drive as a letter. It would select the right letter type, right template, organize it in a way that, this is obviously anonymized, but it would organize it in a way that we would ordinarily do manually. As I was saying, I would save 4 or 5 minutes in actually generating that from scratch. And we've got that almost to 100% accuracy, I would say.
Yeah, it's like 98.
Yeah, 98% accuracy, which is not bad, given large language models having the capacity to make stuff up. So we had quite a lot. We had made quite a lot of effort to make that as accurate as possible. And this is what it actually looks like in our Jiva system. So we've simplified this to a point where we can actually just describe the logic as a flowchart. So we have the original templates, and we can actually keep adding to those templates. It's quite easy to do. We have a couple of GPT calls in there that do all the hard work, and a bit of data engineering in there that ticks out the right elements from the form and then inserts it into the Google Drive. Super simplified. We can actually now describe this. So this took Tanisha how long? A few months to put together collectively. She can now make changes to this or recreate it from scratch just by using natural language on our platform to say, we need to change this to be more conformant to whatever. And it makes that change almost immediately. So we can really rapidly start developing on this type of stuff. So that's pretty much it. I hope I can give you some time back. I just wanted to just have a minute on future activities. So obviously, I had those 3 tracks listed out in the second slide. We want to be able to do this more sort of broadly. We started with less generation. There's obviously lots of administrative tasks that we can bring to the fore, and we're also sort of integrating the SDE, which I hope will mean that people like yourselves, clinicians, non-technical clinical staff, can start using the platform to be able to do those integrations, and so to be able to do those automations yourself without needing to involve the tech department or IT to help you do it. So I'm here to talk to you for the rest of the morning and a bit of the afternoon. So please do come over and talk about what we can do with it.